fasten your seatbelts because here we go. Adaptable manufacturing solutions. The overall theme of this session is focused on how today's woodworking companies need to be able to adapt to opportunities that present themselves and how new technologies are enabling adaptability to become reality. Now, the technology that I'm referring to is already existing and is widely used in everyday life. So it's not new news, but rather the technology that is being directly applied to our industry and our manufacturing solutions. The foundation of this technology is this revolutionary Industry 4.0 and the Internet of Things. These advancements, along with digital solutions created to utilize them, are the core foundation of what we are building today and will drive our industry going forward into the future. So why do we need this? Well, as change is inevitable, your business needs to be able to adapt to the demands of your customers. You need adaptable manufacturing solutions. Change is not always predictable. So ask yourself this question: can you afford to say no to your customers? Before we delve into these new technologies, it's important to understand how we got here. And to help those of you who may not be familiar with Industry 4.0, or as we call it, the fourth industrial revolution, let's spend a moment reviewing that. The first industrial revolution, or Industry 1.0, started in the 1760s and was based around the introduction of mechanization, steam, water power being used to replace what was traditionally accomplished by hand. The second industrial revolution, or Industry 2.0, started in 1870 and was made possible by railroad networks, assembly lines, and thanks to electricity, the telegraph system. Industry 3.0 started in the late 20th century and was driven mostly by better communication systems, supercomputers, industrial machines that are able to replace the need for a specific human action. Which brings us to Industry 4.0, which started in Germany in 2011. Industry 4.0 focuses on 4 distinct design principles: interconnectivity over the Internet of Things, information transparency, technical assistance, and decentralized decisions. Now, I know this may sound like science fiction. However, I can assure you that this is very much science fact. Here are some real-life examples of the Internet of Things in action. Starting at the top left, this self-driving vehicle will encounter traffic, weather, cyclists, and roadworks. And thanks to the Internet of Things, it can learn where the traffic is and plans a detour before it gets there, all while you sip your morning coffee and you read a crisp copy of your favorite morning newspaper. Thermostats that allow you to make changes from outside your home, knowing that you're away by your cell phone location or your status of your home security system, and will reduce the energy costs by adjusting your temperature controls accordingly, all while sending you a text that it did that. Digital speed limit signs, where I'm sure you've seen these around various cities in the US. Using live video feed from traffic cameras, they're able to reduce the speed limit in high volume conditions and raise it back during low volume conditions. Then there are apps that allow you to control devices in your home, lamps, switches, blinds, etc., from wherever you are in the world. You can set scenes to turn on groups of devices based on certain conditions. All of this accessible on multiple smart devices. So after that refresher on Industry 4.0 and how the Internet of Things is already heavily affecting our daily lives, let's explore the effect these technologies are having on our industry specifically. What you see here is the HOMAG PowerTouch, a common digital interface used on multiple machining solutions. This is not just a simple touchscreen added to a PC. but rather a completely new architecture of human-machine interface. The entire operational system was built and designed around touch. Menus are right-sized for fingers. Applications are designed around common features such as pinch and zoom gestures. Information is all displayed in simple to understand icons using colored backgrounds to indicate the current status. Operational systems, program creation, tool management, program simulation, error diagnosis, and machine documentation are just a few of the tools that are available literally at your fingertips. Hey, Tim, I know you know the PowerTouch really well and you use it a lot. While the folks watch this video, perhaps you can mention some of your favorite features.
Sure, John. I'm glad you asked. Yeah, so as we see in the video, and you mentioned, the whole interface has been designed to be touch-centric, right? So we're used to our cell phones and our tablets, all this touch interface. This is a very familiar environment. All the buttons are much larger to enable touch interface. We still have a keyboard and mouse, so we can still input the traditional way. But this interface is also available or being used on all of our machines, from Centitech, StoreTech, SawTech, and EdgeTech machines. So there's that familiarity that we have across the platforms. The drag and drop functionality of PowerTouch is very useful. Tool interface, let's say, available tools on the machine. We can drag and drop those into the tool changer. It's a very visual and interactive experience. We also have, with this redesign on this framework, this PowerTouch interface, we have greater control over user and administrative rights. So we have the ability to give the operator the necessary rights to operate the machine. Yet with a maintenance supervisor, they may have an elevated level of user rights to perform maintenance on the machine. So yeah, PowerTouch, it's been a great thing for us, developed for quite a few years, and yeah, it's a pleasure to use on these machines.
Good information, Tim. Thank you very much for that. So the PowerTouch is a common smart interface used to control the machines, but it also serves as an IoT interface with our other PowerTouch equipped machines and a full suite of digital software solutions. HOMAG iX is a CAD/CAM solution to drive your business from order entry to manufacturing. iX has the ability to easily handle individual and specialized requests, making it highly adaptable to change. It uses a standardized database and is scalable, ensuring it can grow as you grow. Production Manager is effectively a digital folder used to gather all various documents related to work in progress. This could be a PDF, a JPEG, a CSV, Excel, or even CNC files. These files will be available to all approved production personnel to access on the shop floor. This digital folder essentially provides the employees a visual guide through the production process. Material Manager gives you access to your entire material library and inventory at a glance. Trying to plan for an upcoming job? Hey, grab your tablet and Materials Manager will instantly show you how much material you have on hand. Gone are the days of wandering around your facility, aimless and lost, looking for something, or if you don't have it at all. intelliDivide the Nest is a powerful browser-based optimization and nesting tool. The production data is gathered from the cloud, optimized, and nested. The user simply chooses the optimization result and the nested files are created. materialAssist sort allows for better overall organization of the factory, as you always know where the parts are during the production process and what parts are required to be able to be built. Glove-mounted barcode scanners allow employees to freely scan labels without looking for a handheld scanner. When parts are scanned, LEDs clearly indicate the storage section where the parts need to be placed in. Tapio. Tapio is the digital platform for the woodworking industry, and there are currently 12 apps designed to enhance a company's productivity, leveraging the Internet of Things. This slide shows Tapio's machine board displaying live machine production data, maintenance, and service data that is pushed to your smart devices. This allows maintenance to be planned proactively instead of having to react to an issue that has already occurred. The use of Tapio is not brand specific, so more and more of our industry's top companies are using Tapio. You should really take a look at Tapio. So those examples are just some of the digital solutions available that provide today's manufacturers with the ability to adapt. They are easy to use tools designed not only to make your business more productive, but also serve as the platform to attract the next generation of woodworkers to your business because they grew up using devices just like this. Remember, your business needs to be agile. You need to be ready for change. And these digital technologies also help to enable a generation of automated handling solutions that are affordable to companies of all sizes. An automated handling solution of some kind can be applied almost anywhere. Simple solutions, automated loading and unloading, robotics to automatic guided vehicles. There's a right size solution available for you. Automated handling systems drive your productivity. Material is delivered where you need it and when you need it, just in time. Automated handling systems can have a profound impact on your production process and become an invaluable tool. So here's the HOMAG StoreTech storage and retrieval system in action. While you watch the video, I want you to ponder on some of the ways this can positively affect your business. The location of your sheet goods. Where did I put that material again? Increased throughput. How automation paces your production. Reduction of inventory, no more ordering more than you need or what you already have, but you don't realize you have it. Reduce storage space. The store you're watching has approximately 1,200 sheets within it, which would equate to, give or take 32 bunks of material. Think about the space that you have to store 32 bunks of material in the racks and the forklift aisles. Far less material damage. It can even manage materials outside the store, including offcuts. The system verifies what it's picking up, size, weights, etc. It maintains a complete library of your sheet inventory, and it works lights out and can prioritize hot orders. Now let's see the same StoreTech and how it interacts with a nested-based router. As the store is automated and the loading and unloading of the CNC is automated, it provides a vastly increased throughput. The speed that the store loads the speed the store loads the CNC at 8 a.m. is the same at any other time of the day. The store does not get affected by a heavy lunch or partying the night before. A verification check between the store and the router provides yet another automated step. There's far less material damage. The alignment of the sheet on the CNC is also accomplished by automation. The loading device of the CNC can accommodate textured laminates and thin materials. And for delicate surfaces, there are air cushion systems available to minimize granular friction during the unloading sequence. These digital technologies also help provide adaptability to edge processing machines. Ask most owners of an edge processing machine. If they walk into the factory and see the hoods open, pearls of sweat begin to form on their forehead. That's because they know that some inquisitive hands are in there twisting and turning dials with the hope of correcting an issue that quite likely occurred in the station before the one they're adjusting. Sound familiar? Utilizing the technologies and the automation we have discussed so far in this presentation, the new generation of edge processing machines are literally intelligent and thus are adaptable. Some machines have a selectable application unit where the operator, through the power touch, can choose what type of edge to be applied, having multiple glue systems. Some edge processing systems actually position their trimming units using technologies found on CNC machines. So while this video runs, I need to warn you. You're not going to see a lot of action in this video because all the hoods are closed, which is really the point after all, right? All the changeovers are driven by the operator from the power touch control. Many of today's smart processing machines, edge processing machines, have features such as selectable application systems to where the application method, EVA, PUR, AirTech, or Zero Edge as it's called, can easily be chosen. For those of you who may not be familiar with those acronyms, here's a brief overview. EVA, ethylene vinyl acetate, is a hot metal adhesive. Until recently, EVA was the most common form of hot metal adhesive used on edge banders. Supplied in granular form, it is heated to a recommended temperature prior to application. PUR, polyurethane, is a non-reactive hot melt adhesive, which has become more widely used in recent years. PUR is also heated to a recommended temperature before application and is known for its adhesion durability once cured. AirTech is the name of HOMAG's hot air technology used to reactivate a co-extruded polymer layer already applied to the edge band itself. And this is what we call zero edge technology. Zero edge, as you can guess from its name, has a greatly reduced glue joint or reveal. And as an example, where a typical EVA joint would be 0.2 of a millimeter, AirTech would be typically 0.05 of a millimeter, so 75% reduction in that reveal. Other smart features include a unique PUR system, or you can a PUR purge system, or you can simply choose to remove the applications unit and store it short term. The machines also have a servo soft touch feature. It's common for some edge banding trimming units to physically contact the panel to perform an action, whereas the soft touch allows a programmed path, just like you have in a CNC machine. So while we're on the subject of edge processing solutions, here's another example of digital solutions being applied to smart machines. materialAssist Edge allows smart storage of your edge materials. Not only does the system track the actual linear usage of the edge materials and automatically updates the core remnant in the cloud when it's placed back into the rack, but it also uses LEDs that indicate where to find the right coil and where to put it back afterwards. The data is stored in the cloud and is then shared with the edge processing machine itself, which in turn updates the cloud data based on what's been used to process the parts. Mind-boggling, right? Digital solutions at work, and we are just scratching the surface of what's possible with these technologies. If there's one group of machines that has embraced Industry 4.0 and the Internet of Things more than most, it is CNC technology. The adaptability of today's CNCs is quite frankly astonishing. Beyond the benchmark of the Power Touch Common Interface, these smart CNC centers have features such as smart adaptable router spindles that have a unique feedback system from tooltip that allows the machine to adapt to the cutting conditions and make decisions by itself on the fly. Patented drilling technologies to ensure that the required depths are actually achieved. Innovative operators control systems and setup systems from visual LEDs to fully automated setup. Next generation safety systems that scan the area around the machine to know where the operator is. Endless configurations as far as vertical processing, dual horizontal processing, traditional machining centers, and much, much more. 3, 4, or 5-axis systems and different levels of 5-axis based on the application. Some of the 5-axis systems can even accommodate aggregates. And the Woodwop interactive programming system that is backward compatible to 1992 with over 40,000 active users currently. And smart operator tools for assisting in tool setup and changeover. Hey, Tim, I know the tool drop-off and pickup device is one of your favorites, as it's simple and so effective.
Yes, it is, John. With this type of system, the controller keeps track of the tool location, thus eliminating operator errors. It really is a great system.
Yeah, that's really good to know, Tim. I know operator error can be very costly, and obviously that's something that these smart systems, one of the things they're trying to do is eliminate that as much as possible. Thanks for that input.
Yes, sir.
So while CNC routers have been around for many, many years, the fundamental concepts of nesting have evolved greatly in recent years. Nesting is more focused on achieving increased throughput now than ever before, so the machines and technologies have evolved to meet this demand. The following video is going to show you a CNC router nesting cabinet parts equipped with an automatic loading and unload system, which supercharges your productivity. Hey, Tim, I know you've had a lot of experience with nesting, and while the folks watch this, perhaps you want to comment.
Sure. Yeah, so what we're looking at is, this is our N700 series, part of our industrial range of CNC routers. It uses the same benchmark PowerTouch common digital interface that we've been talking about. Since vacuum is key to successful nesting, machine designs have streamlined to optimize total available vacuum. Smart technologies allow the vacuum zoning to automatically adapt to the actual sheet size being used, thus no wasteful venting. The model that we're watching here is equipped with 2 vacuum pumps with a combined 406 CFM of vacuum. Integrated air cushion systems to protect the delicate, high valuable sheet goods that you might be running on the machine. Similar to CNC machining centers, 3, 4, and 5-axis configurations are available. Smart operator tools for assisting in tool setup and changeover, such as the automatic tool change pickup and drop-off station, automatic tool length touch-off device. This machine also has dual rack and pinion drive on the x-axis, dual z-axis ball screws, one for the router and one for the drill block. This machine uses our own HOMAG 17.7 horsepower HSK 63F router spindle. It's also equipped with a 360-degree interpolating C-axis with Flex 5 interface. Behind the machine is a 14-position dynamic carousel tool changer that moves with the machine's x-axis. For drilling, we have a 21-spindle drilling vertical drill block with the HOMAG patented spindle locking mechanism. Reference fences and stops with electronic surveillance, so the machine knows when the stops are up or down. The roller conveyor in feed that you saw the TLF dropping onto. Automatic servo-controlled push-off device, which also has integrated dust and air collection. Dust collection and air. The dust collection from below is at the outfeed side of the panel. So as the panel is outfeeding from the machine, the resulting dust between the cuts in the kerf can be sucked downwards. The driven outfeed conveyor, this actually moves, I don't know if you'll see it in the video, but it moves slightly faster than the sheet is being pushed off. Reason for this is to slightly separate the cut parts so that the dust that's packed into the kerf can be drawn down through that downdraft dust collection. We also have this machine equipped with HOMAG Eco Plus, and it also has a quality package. The video currently shows safety mats, the 4 safety mats in front of the machine, but it's also available with pressure cushions. So this machine does have multiple automated handling concepts. John, can you tell us a little more about the automated handling concepts on this machine?
Absolutely, Tim. I'll be happy to do that. Thanks for that technical overview. There's nobody better or more that I'd rather have do that than you, so thanks for that. As Tim mentioned it, let's take a look at the common handling systems for a CNC router that will be available today. And this is kind of like an overview on your screen now. You can see the concept push out, that is where we typically start, where our automated systems begin. You load the panel, which would typically be manual at this case, with a vacuum lift of some sort, and then the machine would typically automatically outfeed. Concept 2 now adds the auto loading aspect, as it has a scissor lift on the infeed, and then concept 2R would typically be paired with an automated storage and retrieval system, hence the roller infeed, R designation, and the model name. It could also be manually loaded too if you didn't have a store. Concept 3, which is similar to concept 2, however, we now introduce an automatic label printing system on the infeed. Concept 3R would have an automated label infeed and will be primarily designed to connect with the store. Hey, Tim, as you know, one of the most frequently asked questions we receive from a customer is what are the benefits and challenges of nesting routers and machining centers? How about we spend a minute or two discussing that?
Absolutely. It's a subject that comes up a lot. I know our sales team spends a great deal of time talking about the differences to our customers. So between pod and rail machining centers or nesting routers, most commonly we see the nesting routers adapting to sheet goods, full-size panel products, 4x8s, 5x10s, 5x12s, nesting applications, where the pod and rail machines are more adapted or suited for doing individual part processing, where you might have a beam saw earlier on in the production. It's actually cutting those sheets into smaller parts, and then you're processing them on the pod.
Awesome, Tim. I think we should also get some feedback from the audience on this topic, don't you?
Yes, yeah, let's do it.
Awesome, great. So first, it's important to identify what's right for your manufacturing process, and not necessarily this customer has one of these, so I need to have the same thing. One size does not fit all. The types of parts and volume expected plays an important role in deciding what's best for you. There are benefits and challenges to both. So let's take a look at some of these. First, with the nested base router. First, the benefits. It minimizes waste. It reduces material handling. It helps prevent operator error. It combines several machining operations. Has few changeovers, or few changeovers are required. And also it benefits from large vacuum systems. Some of the challenges: horizontal operations are limited. Part height has to be considered. Material yield can be a challenge, especially on higher batches. There are higher utility requirements for a nested machine because of the compressed air and vacuum pumps, and some cleanup would be required. Now let's look at the machining center. First, its benefits. Horizontal operations are unlimited. Greater overall part height ability. Few changeovers are required. And setup and operational systems designed to help prevent operator error. Some of the challenges, minimal cleanup required as well because of the debris falls in the base of the machine. Some of the challenges: nesting of sheet goods is not possible. Now, Tim, I'm sure my email box is going to get flooded after this with contrary thoughts on that. But for this point, we'll say nesting on sheet goods is not possible on machining centers.
I would agree.
Placement of clamping systems is critical. And material yield in small batches can be a challenge. So now that we've outlined some of those benefits and challenges, let's get some feedback from you, our session attendees. So this is your feedback interaction section. It's time for some audience interaction. So folks, this is how it's going to work. Tim and I are going to show you 7 pictures of parts that have been machined on a CNC. Each picture, a polling window will pop up asking you to answer this simple question. What type of machine would this part be typically machined on? And the answers are shown on the screen: 1, 2, or 3. CNC router, CNC machining center, or both. We'll give you a few seconds to answer before the results will be shown, and we will repeat this for each of the 7 pictures. What do you think, Tim? Did I explain that well enough?
Crystal clear, John. Hey, I want to add one part to this. As the polling window pops up, I asked that our attendees, they'll see the polling window pop up. It's probably going to pop up in the middle of the screen. You can just drag that off to the side so that you can see the picture. There's going to be a picture that John is presenting. We want you to be able to see that. So just move that polling window off to the side.
Awesome. Thanks for that. Well, folks, let's get started. Here is your first picture. This is a solid wood fruit bowl made by ourselves in the High Point facility. Go ahead and choose your selections now. We'll give a few seconds here and then we'll show you the results, please.
Did you make that, John?
Actually, no, I know there's a certain applications engineer that did that, I believe.
Oh, that's pretty.
Okay, I think we can see the results now. There you go, Tim, look at that. So we have a difference of opinion, right? We have CNC Machining Center leading the way with 63%. And then we have some CNC router purists out there and folks that say both. Do you want to comment on that one?
I agree, John. I think the folks are listening to you. Look at that.
They are. They are.
Yeah,
it's a good thing.
I think this part could actually be done on either machine. I would agree with the results. We could do this on a nesting machine, but yes, it was actually machined on a point-to-point on a machining center.
Yeah, that's good. All right, so let's move on to the next one, folks. Here we go. So this is some solid surface miter folded. Let's see that voting window, please. Thank you. Tim, I think we really need some like music going on here while the folks make up their mind, right? I'm not going to dance because nobody can see me dance right now, so that's a good thing, believe me. All right, folks, let's see the results of the voting, please. Aha. So this one is a little bit more polarized. We've got folks that typically believe 54% say this will be a CNC router and 40% say both. So I'll take this one, Mr. Wink. In most cases, you would typically want to see this done on a CNC router purely because of the foundation that you have with the spoil board and the flat table of the machine. Now you can put spoil boards or smaller fixtures on the machining center, but the depth of the miter folding is critical. So typically CNC router will be the machine to do that on.
I agree, John. Yep.
All right, next one. This is Tim's favorite part. So let's have the voting done for this. Go ahead, folks, make your selections now.
Yeah, so it looks like, we've got pocket machining and variable Z-depth machining on multiple faces here, John. We've got, and on the top there, you've got almost like a tenon that's gone all 4 faces. So yeah, this looks like a lot of horizontal processing here.
Mm-hmm. And I remember when you showed me that part, I was amazed. So kudos to you. All right, let's see the results of that polling, please. Aha.
Wow.
Look at this. Polarized
Yeah.
here. 84% for the machining center. Tim, I'll let you finish that off.
No, I agree. And this part, I believe I made this part a while back.
You did.
This was made on a point-to-point machine, on a machining center. And it was using a lot of aggregates. It was also using a Flex 5 aggregate. Yeah.
Cool. So let's move on to the next one here. So this is a good one to look at. Here, please make your decisions or your voting now.
So John, this is what I'm looking at. This is like an architectural wall panel, right? That you might
like
see
a wave
in a
wall,
lobby.
exactly.
Yeah.
You see
Usually
that a lot nowadays. Yep.
Yeah, usually very large panels, right? I mean, 4x8 or 5x12 panels are machined with this wave pattern.
All right, folks, let's see how you voted on this one. Aha, here we go. So we have somewhat of a different opinion, but the router purists out there at 67%. What do you think, Tim?
I'm with the CNC router on this because we're talking about a large format panel, and I do have that on a concept machine, anyways. I have that automated loading and offloading. Even if I don't have that, two people can load that sheet onto a flat table machine, and we get a much more consistent result.
Here's the next one. This is going to be a tricky one for you folks. Go ahead and see what you think here. What machine typically would this part be machined on? CNC router, machining center, or both?
That's a base end panel, isn't it? For a base cabinet?
Yeah, Euro base, correct. Yeah.
Okay.
All right. Yeah. So let's see where we are with the results of this one. Aha.
Yes.
So 68% of the folks believe that it could be on both, and I would agree with them, right?
Same here. Yeah.
Because also you could nest these end panels in a nested sheet, or you could pre-cut the blanks on a saw and go straight to the machining center. So kudos to all the smart people out there that chose those answers. All right, let's do the next one. Aha, another tricky one. If we can have the polling window, please. Go ahead and make your choices. What type of machine would this be machined on? CNC router, CNC machining center, or both? And we'll give you a few seconds here to click your answers in before our folks display the answers. This is a tricky one, Tim, don't you think?
Yeah, it is a flat panel cabinet door, right? MDF.
Yeah.
Okay.
So let's see the polling results, please. Aha.
Yeah.
Now this is an interesting one. See, so I'll let you take this one, Tim.
Well, I agree. I mean, obviously you can do this on either machine, but MDF doors are most commonly cut out of a nest, though. So I would tend to lean towards the CNC router. Could it be machined on a pod and rail? Of course it could. But we're talking about in production, you're going to have a nest. You're going to have 20 or 30 of these out of a sheet of material. I would go with a nesting machine also.
Yep, I agree. And last but no means least, as Tim knows, this is my favorite slide to show. Okay, folks, go ahead and choose how you would machine the components for this entry door on the machine, CNC router, machining center, or both. And just while they're discussing that, Tim, so as you know, this is one of our favorite things to do in High Point here, where we manufacture this from SRS to complete door in, 15 minutes or so.
Yeah.
And it's a beautiful demonstration. So I'm glad we included this in our slide. So let's see the results, if we can, of the polling for this one. Aha.
Yeah.
Yes. So let's talk about this for a second. You could actually do this on both machines. It's easier to do it on the machining center because of the debris falling down the base of the machine, but you could also do this on a CNC router, and we've done it. And we've done it to where the machining time, the aggregate time of machining for a CNC machining center doing this or a router is almost identical. But you are right that the CNC machining center would be better overall.
Agree.
So as we begin to close out this section, we explored the profound impact of Industry 4.0 and the Internet of Things on our industry. We showed how digital solutions are driving our industry into the future with sustainable and easy to use tools. Automation and handling systems are becoming integral pieces of today's manufacturing, and they are reliable and pace overall productivity. How advancements in machine technologies make it easy to adapt to changes in production requirements, and how that nested-based routers and CNC machining centers are more capable and adaptable than ever before, helping you become more productive and more adaptable. So that's the presentation portion. Tamika, back to you in mission control for questions.